right, so welcome to the Elixir Roundtable, brought to you by Dockyard. I'm Nathan Long. I'm a senior software engineer at Dockyard.
I'm Mike Benz, also a senior software engineer at Dockyard.
I'm Brian Carterell. I'm the founder of Dockyard.
So we're kind of trying something new here, and today I thought it would be fun to talk about, easy for me to talk about a blog post that I just published called on the Dockyard blog called Elixir is Safe. It was kind of this aha moment for me. So this past week, I think it was, one of our coworkers shared an article that was on the GitHub blog, which prompted a discussion. And it was about it was called How We Found and Fixed a Rare Race Condition in Our Session Handling. Did you guys get a chance to read the GitHub article?
Yeah, I saw it on Hacker News. I think I skimmed through it.
Yeah. It's pretty interesting. Basically, they did some work in a background thread. They're using Ruby on Rails to run GitHub mostly.
Still?
Yeah. And they did some work in a background thread, and there's like this very specific set of events that could happen where one user would be logged in as another user. Like one person got a response back, and it was like,
yeah, I remember it was sometime a few days before that blog post where my session was killed. I think everyone's sessions were killed, and that was part of the post, right? They had to wipe out everyone's session.
Yeah, everybody was logged out. So yeah, that's a horrible bug. And the thing that struck me about it was, I mean, GitHub has a really solid engineering team. I mean, I don't want to diss them at all. Like they're obviously really smart people, and you can tell from the description of how they went about tracking this down that it was not easy to track it down.
Yeah,
and like I was even thinking like not many companies could have tracked it down, to be honest.
So I wonder if this is still the case, but I know for a period of time, I think it was around the Rails 3, when Rails 3 came out, GitHub was maintaining its own separate version of Rails for GitHub core. And I know that they would periodically like merge in patches that were happening on the main Rails repo. I don't know if that's still the case or not, and it'd be interesting to know if it is. Like if they're going out there and saying, hey, we had this problem with, you know, regular standard Ruby and regular standard Rails, that's one thing. But for them to, you know, concede and say, hey, we have this like forked version of everything and we ran into this problem, that makes it a more interesting situation.
I remember hearing about them having their own version. I feel like they went on mainstream Rails at some point after contributing a bunch of stuff. But they did mention in this post that they forked Unicorn because of this bug that they ran into, where Unicorn was part of the problem was there was an env object that was getting like reused, just cleared out between requests, and that mutable data was part of one of the ingredients in this bug. But that they're also contributing that patch upstream, so presumably they'll be back on the main line again. But they were they talked about some of the stuff they went through, like they were reviewing request audit logs, and they could see that like where the session was shared and how it went through their load balancing tier, and that it showed, you know, like these two requests happened in the same process, and just like most companies don't have that kind of that kind of logging to track that down. You know, that's hard.
I imagine the number of times they've probably had denial of service attacks against them, they've had to build up like this, you know, huge ecosystem of audit logging and just metrics and stuff to track things.
Yeah, and I don't want to present Elixir, hopefully it doesn't come across in the article that Elixir is a panacea. I mean, if you're running at GitHub scale, you're going to have some tricky stuff to deal with no matter what you're using. But it kind of clicked for me that like what they dealt with in this particular bug illuminates part of why Elixir's concurrency model is just so good. that the specific thing that happened there was based on immutable data, and the fact that they're having to use multiple threads to presumably they're doing that for performance, and you know, threads are not isolated in Ruby or in any language. So it just kind of clicked for me that the same reason that most of us are using a garbage collected language, because we don't want to deal with the kind of memory bugs that can happen in C. This is what Elixir gives you for concurrency. You know, there's a whole class of bugs that you don't have to deal with. Like this stuff can't happen. There's no mutable data, and you have these shared nothing processes. Like Joe Armstrong had this great analogy of like when two people are talking, I can't reach into your brain and mess with your thoughts, and you can't do that to me.
Not yet. I think Elon Musk is working on that right now.
Okay. That's terrifying. All we can do is pass messages, and so that's how we want our processes to work. But
I
in
think
Elixir,
too that there's a major just benefit from not having to even think about that anymore, right? Like you can then reallocate that part of your brain and all like your brain power to working on domain problems rather than having to worry about edge case type stuff.
Yeah, exactly. And I mean, frankly, I'm intimidated by languages like C. I mean, I'm not intimidated by Rust, even though Rust has a pretty steep learning curve. But like, I know that if I write something in it, it's not going to be, it's not going to like shoot me in the foot, And garbage collection is another way of dealing with that memory stuff. But when you're working in a language like Ruby, or really pretty much any language other than the Beam, your concurrency primitives are OS level processes or threads. That's all you have to work with. I actually went back. I remembered vaguely long ago. It turned out to be 2015, an episode on the Ruby Rogues podcast where they interviewed Mike Perham, who created the Sidekiq library, and he was talking about how the reason he created that was because the existing background job libraries were using OS level threads for each job, and it was just massively inefficient. And he was like, we can do better than this. So he wanted to do something with threads, and that gave him this massive performance boost. The way I remembered it was he dealt with a lot of tricky stuff. It turned out he actually had done this a few times before at different places, and he was like, I don't want to deal with threads directly. So he ended up using Celluloid, which implements an actor library, an actor model in Ruby. But
I've always wondered about that though, like how trustworthy are actor model implementations in languages like Ruby?
Yeah, and I have not used them directly. It was kind of funny going back to this episode because in 2015, I remember hearing that episode, but I didn't understand what an actor model was at that time. Right. And I was just like, okay, I tried to follow along the best I could. And this time it was like, oh, now I get it. That makes sense. Each thread is an actor. They pass messages. But yeah, like Jessica Kerr was on the episode too. She was saying, yeah, she's done stuff like this with actor models in Scala, but they always had to be really careful not to pass mutable data around between their actors because it sounds like you just really don't have those guarantees.
Right.
I don't know exactly how that works with Celluloid. And I also heard that Ruby is adding something called Ractors, which is supposed to be a Ruby implementation of actors, but then like you have to be careful to write your code a certain way. It doesn't work with all existing libraries, and it's like I'm not sure.
Yeah,
I'm not sure how that's going to go.
I mean, we could probably dedicate a whole episode to, because I think that I know Nathan, you were in the Ruby community for a while. Mike, were you doing Ruby prior to this, prior to Elixir?
No, I was actually, I went from Java, came from Java.
Oh, okay, all right. I mean, the whole kind of like evolution of Ruby since I have stopped working in it is a bit odd to me because it feels, and I'm not going to segue into my thing at the moment, but I'm going to touch on this when I do. It kind of feels like they're chasing trends to a certain degree. I do watch like the kind of like the RubyConf keynotes and the every Christmas when they put out the new version of it and see what they've added. But I mean, they're trying to force in a type system, when I understand, or maybe they've already done that at this point. It seems like every version is a new garbage collector. And I had not heard about this actor-based thing that they're putting in there, but I don't know. Maybe there are good excellent like reasons for it, for performance and all this, but it kind of feels like they're getting away from like their core mission, a simple scripting language.
Yeah, I don't know. I mean, I guess I feel kind of two ways about it. Like, one, it feels a little dubious to me, but at the same time, I don't know. We'll see. Maybe it'll work out well. Like,
yeah,
competition.
I mean, I hope it does.
Yeah,
it would be
competition between languages is good for everybody, or at least good for all programming, all programmers. So
yeah.
It'll be interesting to see how that goes. But I think the fundamental thing, it seems like
Actually, I'll add on to that for a second. I think that if we see a benefit from it, hopefully we see more people able to transition over to Elixir because they understand like actors and all those things at that point.
Yeah. But if your VM doesn't build in these guarantees like the Beam does, where data is immutable, you cannot mutate a piece of data that somebody else is using, and you can't mess with the memory in another process. Like that's built into the VM. You just can't screw that up. I don't know that Scala or Ruby or anything else that's Akka and Java I haven't used any of those, but as far as I understand, they don't give you those same kind of guarantees.
Yeah, they're kind of a half step into it, teaching you the concepts, even though the underlying technology doesn't have the solid aspect of the Beam. They're teaching you the concepts, so then like Brian said, you can transfer. You can then it'll make it easier to then transfer over. You learn the concept in Ruby, and then realize, oh, this is what Elixir is doing, but it's actually going to be much more safe.
Yeah, and the other thing that we get in Elixir is the really lightweight processes. I mean, you don't have to have like what they were describing with celluloid. Each actor was a thread, but threads are still pretty heavy compared to processes in Elixir. And in Ruby, as far as I know, they still have the global interpreter lock. So you can do concurrent threads where one of them is waiting on I/O and another one can make progress and actually execute Ruby code. But you can't execute Ruby code in more than one thread at a time. Whereas that's not a problem in Elixir. You spin off your processes; they all execute parallel. As many processors CPUs as you have available. That's your parallel.
How do they manage garbage collection on that on the Ruby side for it? Then is it one global collector, or do all these threads from the Raptor or whatever they're going to be doing have their own GC?
I do not know that. Yeah, that's a good question.
That was one of the things that really drew me into Elixir at the beginning. And I think it was early in Dave Thomas's Prag Prog book where he discussed that. Like that was like one of my early like aha moments. Like, oh, now I understand why it's so fast, because it's not having to stop the world all the time. Like it barely stops each thread has such a small memory footprint, or each process rather in Elixir has such a small memory footprint. It always stays nice and fast. I mean that I feel like at times those that have been doing Elixir for a few years kind of get tired of telling these value propositions over and over again, but we tend to forget that there are always people that are looking and evaluating the language for the first time, and they may not, because these things aren't being really highlighted anymore, they may be going, may not be getting the attention that they should from those outside the ecosystem.
Yeah, I think with the Java project, the main Java project that I worked on before Elixir was document processing. We'd take documents and text files or Word documents, PDFs, and convert them to images to throw them up on the screen in a document viewer. And we wanted to speed this up and do background processing so that when you click the document, it was there because it had already been run. And I remember, we on the beefiest university, it was for admissions at universities, and the biggest client that we had the biggest system had 16 concurrent threads going. And once we spun up to that, we ran into all sorts of just things blocking each other. And like you said, the garbage collection was just a nightmare because it would just pause everything. And then, someone that's if we're trying to get, a less than half a second from click to seeing a document, well, if the entire VM's frozen, that's going to affect everyone else. So yeah, it's a huge problem. And like you said, Elixir it isn't a problem.
Yeah, I think that an aspect of this that I think is really interesting is just the preventing you from making mistakes. Like you can write memory safe code in C, but but the solution is be really, really careful. Like that's what they'll tell you. Like, just be really careful, and that's not a great solution. And you can write good threaded code in Ruby or whatever, but you just have to be really, really careful. And if you screw something up, you're in for a bad time. And like, we just don't have to be that smart when we're using Elixir. Just a lot, like you said, there's a lot less to think about. Like that's a whole bunch of stuff that isn't going to go wrong.
That gets into training too. Is how much if you're trying to train someone up in C, well, you first have to teach them how to allocate memory and not mess it up, and then they need to be an expert in that before they're really able to push code. And if you want to be writing multi-threaded stuff in Java, well, you gotta learn all the different ways you can mess this up and all the things to avoid. Whereas in Elixir, you dive right in, you just start writing what your business logic.
Not only all that, I mean, part of the programming model is to incorporate crashing into it, right? And so like in other languages, you're writing all of this edge case conditional code in order to anticipate what could go wrong. In Elixir, you don't care. I mean, you just let it go, let it get back to a good state and carry on. And that is such a weight off of the shoulders of the engineering team or the engineer that's on the project. They, like I said at the beginning, they could focus on domain value back to the customer. It's I think that, I mean, there's always, I think whenever I have a conversation with anybody, it always devolves into like an Elixir adoption conversation. But there's so many different things that can, speak to the values of Elixir. It can almost feel a bit overwhelming, or it can, for those that aren't doing Elixir, it can also probably feel like, like car sales meeting, right? Like we're promising the world and like it's all these good things, and I'm like, nah, it can't be that good. There's no way it can be that easy, but in many cases it is.
Yeah, and
now I'm picturing Brian, the dentist, asking what software they're running.
Yeah. Hey, what's this? I'll leave that up to the business developers.
Yeah. I think, and like you're talking about the error, the fault tolerance, error isolation. That's really what motivated the initial design of the Beam. Was they weren't so much thinking about concurrency as just like, if one phone conversation blows up on this telephone switch, we don't want the call to 911 to also go down because we had a fault. We had a problem in our like conference call code or something. But we have the same kinds of concerns now with web process, web requests. If one web request blows up, we don't want all the other web requests or web sockets or whatever to go down. And so it has ended up transferring over really well. And I mean, we do rescue errors if there's something that can go wrong and a good way to handle it, then you write that code.
Yeah, but that's more of like kind of like a programming flow thing than anything else, right? Like you're like that the API of said library, or the API you wrote is going to raise a particular error and you capture that, or it's going to return like an error tuple and you match on that. I mean, those aren't necessarily things that you're working around. It's more things that you're incorporating into your code.
Yeah, it's the truly exceptional cases where I didn't expect this to happen that let it crash is great for. I had a blog post a while back about writing a Lullaby player with nerves, and one of the things that happened was there was a part of my code that had to like wait on the sound card to be ready. I'm forgetting the exact details now, but at some point as it's booting up, there would be a process that would try to do something too soon, and it would actually crash, but then it would get restarted. And I didn't even notice that was happening for a long time. And I was like, oh, okay, that there was fault tolerance, just picking right back up and starting that process again until it worked. That's a really neat thing to see. But I hadn't thought about.
Did your baby appreciate the fault tolerance built into the Lullaby?
Absolutely, yes. Yeah.
The self-healing system.
Yes. Daddy, thanks for the self-healing Lullaby player.
Yeah.
Yeah, but Daddy, tell me about the actor model again.
Yeah, exactly. Put me right to sleep.
Yeah, but I mean, so bringing back to this post, I mean, I think the part I hadn't considered was just this security kind of angle. The idea that there's a security benefit to writing our code this way, where we're not dealing with all the mutable state across threads and all this stuff. It's really neat to see that a team as smart as GitHub can get it wrong, and we just don't have to worry about it.
So when I said I skimmed the article, I really skimmed it like fast. And so this is, I guess, a question about the nature of the article. Was this an exploit they discovered, or was this just something that there was a mistake that was out there in the wild?
It was just a mistake, and they had a report from, I think, maybe 2 different users saying that they saw this happen, and they were like, well, it's from everything we can tell, it would be pretty rare that this would happen, but we can't know for sure how many times it's happened. So that's why after they fixed the bug, they logged everybody out. So as far as they know, nobody exploited it, but it's not something you want to mess around with. Like all of a sudden, somebody's got access to the wrong GitHub repos.
Oh yeah,
pretty serious. So I mean, their debugging process, like they talked a lot about, like, this was a massive coordination between all these different areas and expertise and everything. And like, boy, it's impressive, but it's hard, and there's a lot of pain you can avoid if you don't have to use that kind of threading model.
Yeah.
And like I mentioned in the blog post, I didn't go into it, but you can still write concurrency bugs in Elixir if you do something like have 2 different processes read from a database. They each create an update, and then they both write back. You could lose an increment or something, but you still have to be cognizant of atomic updates and stuff like that. But
yeah, I mean, I've been thinking about during this, like, interesting topics for future shows too. And I thought one would be, things we wish were in Elixir, and another one could be like stupid things that break Elixir like quickly, or Phoenix quickly. And one thing that I'm thinking about is the symbols table, like filling that up very quickly, pretty much giving yourself a denial service on your Phoenix application. And that's one area that I think that people don't really. It's not so much to do with what you're referring to. Sorry, my brain's going off in a different direction. I was thinking like simple things that can mess up give you a bad time.
Yeah, and that's a really good point, because I think that also is something I wanted to mention with respect to Elixir processes. Is they're lighter weight than threads, they're more concurrent than threads in languages like Ruby, where you have the GIL, but they are not quite as isolated as operating system processes. Because like you're saying, if you allocate too many atoms, if you're just like, if every string that comes in you make an atom out of it, then you're gonna end up eating up all the memory and the whole node, the whole OS process for the beam, and you actually could crash all of the processes that way. So
for those that don't know, symbols don't get garbage collected.
Yeah.
So if you're interpolating your strings into symbols for whatever reason, and those are exposed to like user data that's coming in over requests, someone can figure that out and just start spamming your system with like more and more strings, and then crash your system.
Yeah. Symbols meaning atoms.
Atoms, sorry. Yeah, we were talking about Ruby. My brain's in Ruby world. Sorry, atoms.
Yes. Yeah.
The same problem exists in Ruby though.
Yeah. Although I think they actually ended up fixing that in Ruby at some point. They actually, I think they do garbage collect symbols at this point.
Oh, really? Because I thought the whole point of symbols was for performance reasons.
I could be wrong.
I don't. It could have happened in Ruby. I just don't know.
Internally, it's just they convert it to a number, right?
They're strings, I believe, internally. It's just that they're like that particular. I mean, Luke would probably know much better, but I believe that they're just kept in a table, and because when they get allocated upon instantiation, the next time they're just looked up rather than instantiated again, and so you don't have to deal with the cost overhead, even though it's tiny, the cost overhead, and then they just never get collected.
Yeah, they definitely don't get collected in the beam, and so you can definitely get get into trouble that way. And there's other things you can do that can crash the whole VM, but it's pretty hard to do.
Yeah,
I think that list is pretty short.
That'd be an interesting contest. Who can crash the beam in the most interesting way?
That would be.
This is the next Phoenix Frenzy round.
Yeah.
Mine was I was doing a board game, and I was trying to write the AI to walk the tree for min maxing, and it got up to 2 million threads, because I was task asyncing. It was a horribly inefficient design, but it would 5 levels down, the whole thing blew up, and So.
Was this the NX game that you're doing?
So I took a pass at trying to upgrade that into NX. It's something I wrote it like 4 or 5 years ago. Because
it's like a physical board game, right? What's the name of it?
Yeah, Mancala. It's a simple board game, but that my like I said, my initial one was just task.async, but it did it at every level of so it was trying to walk the entire tree, and so like I said,
so you had tasks spawning tasks.
Yeah, it was horrible. I think
that's called a fork bomb, right?
Yeah, exactly. It was a mess, but
that's a good one.
Yeah, so you can fork bomb yourself. But like that's pretty much the only situation where you're going to create too many processes for the beam. I mean, generally speaking, you can just create processes and not think about it. Yeah, we could talk more about those kinds of things on another episode. Or
just get more memory for your computer. Come on, Mike.
There you go.
Yeah. You can break anything. You just have to know how.
Move on to the next topic.
Sure.
Mike, do you want to go?
No,
you're shaking your head.
Not me. I'm here for the conversation. I didn't actually bring a topic this time.
Okay, I got a topic then. All right, so I've been doing Swift for the past couple of weeks, and this is related to Elixir, but I'm going to make a mea culpa. For the past few years, I've been nagging Jose and saying on various podcasts and probably on stages at conferences that we want a strong type system in Elixir. And after doing Swift for the past few weeks, I am completely pulling back every request I've made for a type system ever. I've done strongly typed languages in the past, but since I did Ruby 10 years ago and Elixir, and I don't know what the hell JavaScript is, but it's definitely not strongly typed. TypeScript is. But I've been so far into like the weakly typed languages. Going back to it is just, it feels like unnecessary overhead. And I think part of that is due to a couple things. Number one, Elixir has a set limited number of types, right? And so pretty much anything you want to represent is represented by just a few types. Like it's not like you have a date struct or whatever it is in Elixir, but it's really just a tuple, like down underneath. You have maps that are pretty simple. You have strings, integers, et cetera, et cetera. Whereas in Swift, I mean, it's a whole bunch of stuff, but then they have what feel like a lot of workarounds integrated into the language in order to get things done. And so there are types called like any hashable, any object, any et cetera, any collectible that can then essentially type match up against anything. But then if you're dealing with, like if you have JSON data coming in, right, and you're parsing the JSON data, the JSON data isn't necessarily going to conform to Swift's desire to keep everything, like every value within an array isn't always going to be an integer or a string. It's, sometimes it can be mixed, especially if you don't have control over that service that you're requesting data from. And so it feels like a lot of hoops you're jumping through in order to accommodate it. And Elixir's pattern matching system, I think, gets you most of what you want from a type system anyway. there's dialyzer, but I think dialyzer's real value is only in documentation, not so much in practicality. I know that you can run dialyzer, but I've never had much success with it as a specification kind of guide. But yeah, I'm kind of stuck in Swift world right now, and I think part of it too is I'm actually porting over some Elixir code into Swift, and so I'm not exactly writing it in the most idiomatic Swift fashion. I'm kind of writing it in a cross between Swift, like Swift's object model, and then some functional programming-ish type things, just so that, because it works in Elixir, and moving it over to Swift with my limited Swift knowledge, I'm essentially just kind of taking the test data on the Elixir side and then copying the implementation. And so hopefully in the future, someone that has better Swift knowledge can rewrite this in a more idiomatic Swift fashion, but it's not going to be me, because I'm going to get this early part done and hopefully pass it along. And so I actually texted Jose yesterday, and I told him, I'm sorry for ever wanting a type system in Elixir, and he just laughed. So this is my my official mea culpa. I will no longer request a type system in Elixir as the things I want there. I changed my request though. I want a functional first class debugger in Elixir. And so the Erlang debugger that's there, like it's like int ini or whatever, and then kind of latch onto a module. It'd be really nice if there was a way that, and maybe this already exists, I just don't know about it, but if it was integrated into VS Code, it could use like VS Code's breakpoint debugging system, like it's its own testing hooks or whatever. However VS Code works, where it can then talk to the language server in order to facilitate the debugging. It'd be really nice. The debugger for the Erlang debugger is okay if you're more accustomed to seeing Erlang code, but if you're not, then I don't know what was going through their mind when they decided how they were going to eliminate strings when developing Erlang. Like those, like less than, greater than surrounding the binary statements. Like my brain just goes haywire when I see that. But I don't know. What are your thoughts on that? Because I know that Jose for a while was talking about an inferred type system that I guess was impossible to get working. And then I've heard rumblings over this past year, that there was something being worked on as a type system goes. But maybe they'll come out with something that's awesome that I won't have an issue with. But if it's anything like Swift's, then no, thank you.
Yeah, I think so. Coming from Java, obviously one of the things I really liked about it was the ability to refactor stuff quickly, because you could make a change and it would bleed all over the place, and you go through and just clean up the stuff that you changed. And so I think Elixir is getting better at a lot of that. One of the things that we Jason and I had talked a lot about is nil creep, and the idea of maps. And if you get the key wrong in a struct, it's just gonna you'll have a nil dropped in your code wherever. And the recent changes, I want to say 1.11, where it understands that better, and it'll warn you if in the head of your function you've got your pattern matching against a struct, and then later you use that object and you hit a key that isn't part of that struct, it'll let you know.
Are you referring to like the improved errors that are coming out of Erlang? I think Jose tweeted about it last week. Or
no, that's a different cool thing, which
okay.
is its own nice thing. But yeah, no, this is understanding the compiler understanding or determining that something is a struct, and then later on in that same piece of code, if you try to use a field that isn't on that struct, it'll warn you.
It'll give you that warning at compile time, right?
At compile time, right? Exactly.
Oh, okay.
Yeah,
that's
yeah. So that sort of stuff is good. And honestly, you know, Chris isn't here, so I can you know, I can give one side of the argument. Dialyzer does for me what I liked in Java, which is I make a change, and you know, somewhere I hadn't touched in months, a completely different file that was expecting something. Now it's going to say, hey, actually, you know, this is wrong.
What editor are you using?
VS Code.
Really? I've never gotten it to work. Like I've gotten it to work because I've written dialyzer code and spec'd up some of my own libraries, but especially if I pull in someone else's repo, like rebuilding it always like what tab is it in VS Code? Hold on. There's like one tab that's always broken. It's like the problems tab. Like in the problems tab, there's always like 15 problems, and they're all dialyzer type problems.
Well, yeah. Well, that's the thing is, so you know, this is the conversation we have pretty regularly here. Is
I haven't been here for a while, so
yeah. Well, so dialyzer, yeah. There's frequent Slack, you know, back and forths. Dialyzer has an overhead to use it, and if you can learn how to use it and learn how to interpret it, because it's not clear, it's not, you know, oftentimes it'll say something but mean something completely different. If you learn how to do that, it's helpful. And for, you know, so you know, Chris doesn't feel like that overhead is worth it, and it isn't, I think, for him, because he writes code. I think the better you are at Elixir, and the better you are at being able to write good code the first time, the less helpful dialyzer is. It just kind of gets in the way and is annoying. But if you're new to it, you know, I think there's a lot more value in having those guardrails to say, hey, you know, what you're trying to do is you know, this isn't going to work.
Yeah, I'm sympathetic to that argument, because I am getting the benefit of the type system in Swift through Xcode. And like, it is warning me that these return types are expected, like do this. And the static analysis tools are interesting because it can suggest fixes. Mm-hmm. It's like 50-50 on whether or not the fix makes the code look horrible. Yeah. But I think that if the language wasn't strongly typed, some of these things wouldn't be necessary in the first place. And I mean, yeah. I understand why Swift is strongly typed, because Apple wants to reduce all likelihood of runtime errors on their platform, and that's part of their intended user experience. Like, I totally get that. It's just, I think for specifically what I'm doing, and if this was the experience that I would have writing Elixir all the time, because also the amount of verbosity of the code that you have to end up writing is, like, for example, I took a Elixir function that was probably like 3 or 4 lines of code, and in Swift it ends up being about 20 lines of code, and just all this additional ceremony and stuff you have to write on top of it, that just to support the type system, that feels just feels like I'm going through the motions just to satisfy the editor at times, more than just getting my thing done.
I know it's a little bit of a double-edged sword there, because I remember with Java, yeah, there was more boilerplate you had to write, but the editor could figure it out most of the time. So if you're like, right, if you want a new field, you just access it, and it's like, hey, this doesn't exist. Do you want to create it? Click, and it's done. So it's what it sounds like is you got two options. You got strongly typed languages like Swift that have to work their way towards the center by giving you the NEs and the those sort of things. And you have the weakly type systems that have things like dialyzer that bring you more towards the center. So like, it's either one you're shifting.
I'm probably speaking out of turn here, like most times, but I did talk to Sean Moriarty, who is writing NX along with Jose. I chatted with him briefly about, as I kind of posed this question to him, like, can NX or the higher level abstraction that he's currently working on be used for code hinting and code suggestions and error checking and some sort of static analysis of your Elixir code? And at first it's like, no, I don't think that's possible. And then he came back to me a week later, and it kind of like, it seemed like he was eating at his head, and he started looking into it. And he did a little bit of research on it. He said that, this may be possible, and maybe I don't want to put that job on his shoulders, but it'd be really nice if that could work, incorporating kind of the results of the NX project back into the Elixir language server, in order to get some of that code hinting and suggestions and analysis without having to go through all of the hoops of setting up your types and such.
I haven't done a lot of work in strongly typed languages. I've done a little bit of Rust kind of on the side for learning purposes. Got as far as publishing a crate. I mean, one of the things I thought was cool about it was, if, like, for example, if you do like a file open call and then you match on the result of that, the compiler knows that there can be a success or a failure returned from that. And so if you just like match and only handle the success case, you can't compile. It's like you have to handle the failure case.
That's interesting. Yeah, they don't have that in Swift.
Yeah.
It's more like, Matt, you kind of set your type to your variable, and I guess it'd be kind of, that's actually pretty advanced code analysis then. I mean, I assume that happens when you compile the code. It's not in the editor.
Right. It's so for something like that, that seems like it makes sense, because it's like the difference between, expected versus unexpected error conditions. Like it is expected that sometimes the file isn't going to be there, and you should deal with that. But yeah, when I'm using dialyzer, I feel kind of two ways about it. Like I like it in theory, and I think it can give good help, and avoiding bugs. It does feel like a lot of work, and my main beef is just that the error messages are so confusing and inscrutable that it's like, basically a lot of times I'm just like, well, something is wrong. And so all I know is something is wrong, and I have to do something about it, and I'll have to like stare at it until I figure that out.
That's been my experience too, that I for a while I tried to drive my code with the specs in dialyzer, and I would just get bogged down in esoteric error messages that would just take a while. And I guess that's really just an experience thing. If you do it enough, I guess you get past it. But I ultimately just really started using dialyzer for the annotation of the documentation, rather than kind of driving my code quality.
I've actually moved away from specs for the most part, and the benefits I've had from dialyzer have actually been the things that it picks up even without specs are generally most of the way there. And you're right, if you start putting specs on everything, that's something you have to maintain, and you get one of those wrong, and you get some weird crazy message that really just ends up being the spec wasn't right. So I've actually, like I said, I don't actually put specs on most of the stuff. If there's an issue, or there's something that a dialyzer message that I can't figure out, I'll actually put specs on it to say what I assume that it's going to be, and then it'll tell me whether that's right or wrong. But yeah, I think a lot of the confusing error messages and a lot of the frustration ends up being incorrect spec, and so
that could that's a fair.
That is to
I think that's totally fair. I mean, I'm not claiming to be dialyzer expert, and so it's very likely that in many cases I wasn't using it properly.
Yeah. So for me, I found it just not not doing them in most cases. If they got a behavior or something where I've got callbacks and whatever where you need to and maybe at boundaries, so where it's very clear. But yeah, specs everywhere turns into dialyzer blood everywhere. It's just you get errors, errors all over, and so that dialyzer is smart. It can tell when there's a dialyzer is always right. It's just not always clear as to what the problem is.
It's right, but it's an asshole.
yeah. So. Yeah.
There was a talk that Gary Bernhardt gave at one point called Ideology, where he talked about like static typing people versus test driven people, and like they each kind of think that this is a panacea, and like static typing is he said it's really cool for making certain undefined behaviors impossible. Like if you're supposed to pass a number, you can't pass a string, and you're not going to have an error there.
Yeah.
But you can pass a number that's too big or too small, probably, and so there's things that it can constrain and things that it can't constrain.
I got a question for each of you. What percentage of your code that you're writing are you guys TDDing?
Pretty small.
Yeah, I'm the same way. I mean, I think when I was in my career, as I drank the Kool-Aid on TDD, I was somewhere between junior and mid, especially like heading definitely in the meaty part of the mid curve. I got to TDD everything right away, but it's it's got to be well below 25% of my code that I TDD.
Yeah, I would say the same. I think the times when I break out test-driven development or even sometimes testing after the fact, but just testing very thoroughly, is when I'm writing a piece of code that I feel is tricky. Like I'm not sure I'm going to get this right. So, for example, I wrote some code on a client project where there's a bunch of timings that I wanted to display in a little SVG graph, kind of like if you looked in the Chrome inspector where it shows requests and how long they took. And so each bar needs to be displayed at the correct length, and you don't want to put like 1 bar per row because it'd be really tall. So you want to sort of like pack them in as densely as you can. So I wanted to render an SVG like that, and I felt like that code was going to be tricky to write in terms of like deciding how long should each thing be and what row should it be on. So I TDD'd that, and that helped me make sure that I was getting that right, and it turned out to work well. But yeah,
I find in a lot of cases, like when I'm exploring the model of the application or the library, I don't even know what I want like the return values of these functions to be yet. I have a general concept on it, and so like I feel like spiking things out and playing in the code that way for me is a lot more performant. And the kind of practitioners of TDD will come back and say like, oh, and then you come back and write the test, and now you're just testing, like their tests are asserting potential bugs in the code. I mean, I have a hard time buying that argument after programming for 20 years. I think that there are, unless you're writing like 100-line functions, something with like all these, weird, just branching logic in it. I think that testing TDD is another tool that you can have at your disposal to help you write good code. It isn't the tool. It's not the only tool. And that's where I think in the past maybe 8 or 9 years is where I've kind of come to land on that subject.
Yeah, I heard a good conversation at one point where they were talking about, basically the purpose of testing and any other technique is to increase your confidence that your code is doing the right thing. And so on code where I know like this is easy, I don't feel like I have to test this real hard. But then, when I'm doing something that I feel is kind of like, I'm not sure I'm going to do this right, then I double down on whatever I can do to give it more correctness guarantees.
Yeah. I think integration tests, behavioral tests that are testing multiple systems in combination are probably good areas that you should probably spend a bit more time on your tests, but unit tests on individual functions, especially ones that are otherwise covered by integration tests, are by large unnecessary.
Yeah, it ends up being more to maintain that.
Oh yeah.
Yeah.
I mean, this is my whole rant against, like, we were talking about, type specs, but like testing specs, the R spec from Ruby World. And I know that there's a spec implementation for Elixir, but I don't know what it is. But these, like, engineers love complexity. I'm convinced, and they like, drying up their code and trying to reduce and reuse everything. And the nail in the coffin, I think, is when you start to apply those things to your test suite. And now you start to try to get too clever, and you're going to start like, okay, that test is kind of like this one, and if I just change them both a little bit and then combine them, and like before you know, you have like one like macro for your entire test suite, and it's a nightmare for anyone else coming in to use it. And it's I mean, that's always something that I've driven at Dockyard when I was running the engineering team, was keep it as simple as possible. Anytime you feel like it's getting too complex, and if you go back to the code after a week later and you have to relearn what it was you were doing a week ago, like, that's a problem.
We had a recent client that our stand up whenever we had the stand up, I'd always ask the question, what did we do with this client today to reduce complexity? And it was a serious question, and it got people thinking, like, there's a super fun, interesting, complex way of solving this problem, but there's also a nice and easy way that isn't as fun, but can be done and much easier to be maintained.
Oh yeah, no, absolutely. And that fun complex problem is going to probably impress like 3 people, right?
do those on your Dockyard Fridays.
Yeah, exactly.
So
yeah. Yep. Well, this is probably a good place for us to wrap up. So if anybody's watching, thanks for joining us.
Smash like and subscribe.
Yeah, push
that's all the stupid stuff all the YouTubers say.
Yeah, tell all your friends that they need
to
like channel.
Yeah, give us money.
All right, well, this was fun. Thanks, guys.
All right.
Thanks.
See ya.